power temperature coefficients, very similar to NOCT. The change in the panel output power for temperature other than 25%. And here, in this particular, I want to look at degrees versus power. I'm not so interested about percentages. This is a practical slide. The surface temperature is about 70 degrees C in hot area. Now, if the power rating, according to the technical specification of the manufacturer, the panel manufacturer, is 200 watts at the STC, standard test conditions, it will go down to 155 if the surface temperature is 70 degrees. We're losing 45 watts each panel. And if we have a 100 kilowatts system or 1 megawatt system with, let's say, 100,000 panels, each of them lose 45 watts, that's a tremendous loss. So I'm not interested at this slide talking about percentages. I'm trying for you to appreciate the loss of watts, the loss of power because of the temperature coefficient. Especially when we come to build a large farm. But in a private home, when we have 25 panels on the roof, each panel losing 45 watts, that's a loss of 9 kilowatts per day. Per hour, depends where we are. That's a loss of money. That means that the same system will not be able to supply my consumption. So the temperature coefficient becomes very, very, very important parameter. That's maybe number one parameter looking at the technical specification of a PV panel. Thin film panels have relatively low temperature coefficients, makes them better, which reflects better in high temperature areas, performances. However, their total efficiency level is lower, as we've seen before. So in very hot places, sometimes it's preferred to use thin film technology.